Anyways, if we go back to our private leaderboards, we can see we're top banana on the work private leaderboard. We're ahead by 3 days worth of one position. Basically, if you finish each problem like one position above, you get an additional point, and there's 2 starts per day. So we got about a 3-day buffer as long as we're finishing first or second. As long as we're finishing second specifically to Brian Kendall. We'll see whether or not that keeps going. No Hey Dev, I think, has been a little bit slower because he keeps watching us before he goes and does the solutions. Similarly with Puff, although I think they're in harder time zones to do some of this stuff. Maybe they'll drop by tonight. Unclear. Then between me and Ryan, it looks like Ryan caught me on one of them, which we discussed last night. Yeah. So if we go back, 3 minutes and 13 seconds. Oh, and if we check fantasy football, it looks like I will be winning this week. Thank goodness. It was a rough week for us. We had Cortland Sutton, who was questionable and missed his only target of the day, so he had 0 points. Jalen Waddle was fine for most of the game, but only had 1 reception for 9 yards. That's on 5 targets. He was 0 for 4, and then he finally caught a pass, but just a bad week for him. And the New York Jets defense did not do great, but we should have expected that. Minnesota's better than people have been giving them credit for, and by people I mostly mean me. I've had the Jets defense for the last couple of weeks, and I just haven't been moving around. Also, Aaron Jones got injured, but he got injured after scoring 10 points, so that keeps us comfortable. Luckily, our opponent has no more players to play. Kenneth Walker only scored 3.6. Yikes! And looks like Lamar Jackson got injured, which is just terrible for him. I like him as a player. And we still have Mike Evans, so as long as Mike Evans doesn't fumble 4 times on no receptions, I think we'll be okay. And looking... I'm trying to figure out who I need. Oh, dang. Looks like Thomas is going to win. Off of Keenan Allen having a huge day. Good for him. And Brady Bunch is going to lose. We needed to see that. Yeah, and Tommy's going to stick in there too. And then it's 50-50 whether or not John or Chowder's going to win. So unclear there. And now we hear the end of the song. We move to the tab where the songs are. There we go. The beginning of this always sounds like a just elevator music to me. Went for an 8-mile run earlier today. That's got me pretty tired. It was pretty good. I was running about 8:40 pace for 8.03 miles. It took just under an hour 10. An hour, 9 minutes, 43 seconds. I'm pretty rough. Not a ton of elevation gain, maybe 200 feet total, but 1,300 calories burned. So no complaints there. Pace was pretty good. Heart rate in the 170 range. Gonna have to figure out whether or not that means anything for us. Also, my girlfriend and my roommate are watching Love Island, so if you hear some ladies giggling in the background, that's probably what's going on there. Whew. Looks like Drapsnat is back. Hope you're having a good day, Drapsnat. Oh, that appears to be a really old account that is also one of these fake accounts that shows up as a viewer. But hey, we live with that. All right, 12 seconds. Oh, it's time to dial in. Here we go. Now let's check. We do have level 5 part 1. And we're still going to be reading these out loud. We're not trying to go crazy fast, but I would like to get there. Day 5, supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forget to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. For example, this drawing, and then it's going to make this set of moves. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z on the bottom, crate N is on the top. Stack 2 contains 3 crates. From bottom to top, there are M, C, and D. And finally, stack 3 contains a single crate, P. Then, the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, one crate is moved from stack 2 to stack 1, resulting in this configuration. In the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved one at a time, so the first crate to be moved, D, ends up below the second and third crates. Then, both crates are moved from stack 2 to 1 again. Again, because crates are moved one at a time, crate C ends up below crate M, so we're going to be using a bunch of stacks. Finally, one crate is moved from stack 1 to stack 2. The L's just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. So you should combine these together and give the message CMZ. After the rearrangement procedure completes, what crate ends up on top of each stack? Okay, let's get our puzzle input. So it looks like there are 9 crates, and then there's a bunch of stuff that's going to be done here. No problem. So let's try and figure out how to parse this. So we want to do for the first... We want to parse the first 8 lines. So let's see. I want a stack, and I want an array list of stacks of character. And this is like loading doc equals new array list. For int I equals 0, I is less than, and let's see, how do these get numbered 1 to 9? So we want 0 to 8, so less than 9, plus plus I, loading doc, dot add, new stack, character. Cool. So now, line count equals, so we want to basically like parse through the top several things. Let's get the music going. There we go. So we want to parse 8 lines here. 8 while line count greater than 0. Whoop, that's not what we're looking for. There we go. Got to turn down the sound of my headset a little bit. And the last thing we want to do is minus minus line count when we do this. And then we want to say string line equals scanner dot next line. Let's see, we want characters 1, 2, 3, 4, 5. So 0, 1, 3, 4, 5. Right, so it's if we just write down the numbers real quick of the things, 1, 2, oh no, not what I was looking for. 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. This is gonna help me keep track of where the things are. So it looks like the characters are on, oh, except there needs to be a 0 here. So 1, 5, 9, 13. So basically, etc., etc. So to get the index from the thing, I need to subtract 1 and then divide by 4. That's a little too hard. Why don't I just check for these? So for int I equals, and let's see, are these padded appropriately? They're not, but I can make them padded appropriately. Actually, we can just put a check in there. For I equals 1, I plus equals 4 is the thing, and then we want to go like I is less than something. What's the thing here? 10, 20, 30, 36? Sure. Because the highest one is 33, so that should be fine. If line dot length is greater than I, let's see, I is less than, nope, line dot length and I is less than 36. Because then it'll just terminate when we've gotten too far. If line dot char I not equal this, because that's the only thing that could be there, right? Just a space. Oh no, we did something there. I don't actually, I don't care about that. Then we want loading doc dot get int which stack equals I minus 1, and then we want to get that divided by 4 to get which stack dot push line dot char I. Great, so that should in theory do the stuff. So let's take this part and let's see if we can put a continue statement here, and let's see if we can just debug this part. I know that we should be able to continue going, but why are we upset? There we go. All right, please take me back to this and debug. Continue outside of loop. Okay, pass. What's the nothing operator? Int x equals 3. Fine. We'll just make a new variable that does nothing, and then I want to see when we're at in x equals 3 loading doc, and we've got 0 has j f c n d b w, and if I look at the data j f c n d b w, and let's look at 4 chb zjl td. 4 is, oops, that should be 3. CHB, ZJL, TD. Okay, cool. So we're parsing the input correctly. Let's get the music going again. There we go. Much better. Okay, so now that we've parsed that input correctly, now we need to read the empty lines that come. So first of all, let's delete these. So now we want scanner read line, and then we're going to go there. Scanner dot next line. Scanner dot next line. We're abusing the side effects. Let's go ahead and put a line. Data. We can uncomment this. String command equals scanner dot next line. And then we want 3 things. So we want the number to move, what we're moving it from, and what we're moving it to. So this is at position 0, 1, 2, 3, 4, 5. Int how many equals command dot caret index. What did we say it was? 5? 0, 1, 2, 3, 4, 5. Right? And that's, oh no, we just want to split it on spaces. Well. String commands is this dot split on space. There's no better thing for us to split it on, right? Yeah, sure. So now we want this one, and this one. So that's 1, 3, and 5. So this is integer dot parse int commands 1. Int from stack equals integer dot parse int commands 3. Why are we upset? What are we mad about? We should be fine. What's upsetting about this regex? Does it need to be this? This needs to be a string array. There we go. And int to stack equals integer dot parse int commands 5. I wonder what part 2 is going to be today. So then we just want to implement this. For int I equals 0, I is less than how many, and we want this minus 1 so we get the right index. Plus plus I. So then we want loading doc dot get from stack dot pop, and we want to push that into loading dock dot get to stack dot push, and then please push this. Let's go ahead and tab that so it's a little easier. So we're basically just popping stuff and pushing stuff. And then at the end, top boxes. And then what we want to do is, and we actually don't want the line here. For int I equals 0, I is less than 9 plus I. So then we want loading dock dot get I dot peak, and we want to print that out. System dot out dot fine, put println. We'll fix that in a second. Print this, and that should be good. So let's try running that. Run that, please. Top box is this. Did it work? Did we do it? Not the right answer. Return to day 5. Let's try running it on this set of inputs, which is gonna get a little bit mad, but actually should be fine because we're just not gonna put anything into the other ones. So let's try that, and then see if that gets it correct for us. So now if we run it, file not found, no line found. Oh, we want to change the number of lines to 3. Top boxes, CDN file not found, no. What are we upset about? Let's try debugging. See where we're getting wrong with our test data. So we're going to add a bunch of loading docks. Please continue. Blah, 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 blah. Here, just add a new thing here. Line count is 3. Grab the line. Cool. So now line count is 2. Now line count is 1. It says ZMP, which is the bottom of this file, so we should be fine. Yeah. Now scanner dot get line, scanner dot let. So now what is the scanner looking at? So now what's in commands? 1 2 2, 1 1 2 1. Great. Which is already pulling out for us. Yeah, move 1 from 2 to 1. Move 1 from 2 to 1. Ooh, 1 from 1 to 0 is what it should be. Wonderful. So now we're going to take... So let's look at our loading dock real quick, see if it's doing the right thing. So 0, 1, and 2 are all in there. So we start off with DCM, etc., right? So now we're going to pop 1 from 1. So the D is going to get popped and it's going to get put on top of NZ. So now if we look at the loading dock, N is on top of ZM. Wonderful, wonderful. P. Okay. Scanner should still have another line. Blah, 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 blah. Doing fine. Okay, so it moved the 3 things. So now everything should be in like 3 basically, right? Which it is. That's fine. Blah, blah, blah. And so now it's going to move some stuff over again. And so now some stuff is going to be in 1. So now there's stuff in 1, which is... Oh, why does it say CD? Oh, no. What did we mess up? What did we mess up? Oh, it's because we push stuff in backwards. Is there any way to reverse a stack? Like, how do we do that quickly? Yeah, we're idiots. Read from the top to the bottom. So reverse each stack because we read them in from top to bottom. For anti equals 0, I is less than 9. And let's just see if there's a function that does what we want. Loading doc dot get I dot let's see. I'm trying to think if there's a fast way to do this. Oh, there's apparently a collections thing that'll do this. Sort collections dot reverse order. Okay, let's see if that does it now. Where's the, so let's stop and rerun. Oh wait, no, and this is including a line that's gonna totally bork everything. Stop the presses, fix the debugger. Okay, play through, play through. So now let's look at our loading doc. 0, the 0th item is Z. The item above that is N. So that is going to be what we want. So let's see if we just get to this point. Play through. We have D. We have M. And we have P, C, and Z. Something's still coming out funky. Okay, let's debug that one more time. Stop and rerun. Let's look and make sure that the input's exactly the same, right? NC, DCM, P. Okay, so that's all correct. And so now that we're at this point, we can do all this. So at this point, let's check all three. So this one is M, D, C. Oh no, because it's actually looking at the elements. I don't want to look at the elements. I just want to flip them. That's not fair. I mean, it is fair. What am I talking about? That is unfortunate that that works that way. I thought we had like a catch-all here. Is there like a collections.toArray? This, I don't want to sort it. To array, and so this is a character array. Temp equals this, and then we basically want to, yeah, we can cast this. We know what it is. And then we basically want to say loading doc dot get I dot clear, and then we want to say for int I equals 0, I is less than temp dot length plus I. It's not clear to me what exactly we're going to want to do here. Let's try it. Let's see what happens. Loading dot get I dot push temp I. Let's see if this results in the same before and after. So if we debug this code, stop and rerun, variable I is already defined. That is fair. Make these J's. J, 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 J. No, that needs to be I. Oh no. I dot push temp J. Well, yeah, that makes sense. We would need to have different things there. Totally reasonable. Play, play. Okay. So if we go here and we look at loading dock, we have N, and then on top of it we have Z. What exception did we catch? Class cast exception. Oh, it's mad. It doesn't think that this is a character array. But why not? It's a stack. Here, let's do this. Equals new character, and we want it to be loading doc.get I dot size. We want it to be that big, and then we can toArray, and we can put it in temp. There you go. Now you don't have to worry about all the weird assignment stuff. We can just, there. Are you happier now? Let's find out. Stop and rerun. Yep. Okay. So we've got this thing, and the loading doc 0 is N and then Z, which is wrong because it should be Z and then N. So now if we go down, then we get it. And temp is N and then Z. So we need to do this in reverse order because this is just going to push N and then Z. We want Z and then N. So yeah, at the end of this, loading doc thing is N and then Z, right? So we want this to push temp.length minus J minus 1. Okay, now let's just go ahead and try and run this and see what happens. It's gonna be mad, but hopefully it'll be mad after CMZ. CMZ, wonderful. Okay, cool. Let's take my input again. Let's take this whole thing. That was way harder than it should have been. File not pound for input string V. What? Okay, what did I... Oh. This line count needs to go back to 8. It's a good thing we just hard-coded some constants. LBL, blah, 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 blah. Hey, we did it. All right, that was a very slow part 1. Part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a crane mover 9000. It's a crane mover 9001. It's over 9000! The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Moving a single stack from crate 2 to 1 behaves the same. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order. The result in this new configuration. Next, as both crates are moved from stack 2 to stack 1, they retain their order as well. Finally, the single crate that gets moved from stack 2 to 1. In this example, the crate mover has put the crates in a totally different order, MCD. Before the rearrangement process finishes, update your simulation so the elves know where they should be ready to unload the final supplies. After rearrangement, what crates end up on top of each stack. Okay, so let's copy our whole try section. And then we'll take this part. Boom. Okay, cool. So now what do we need to modify? We need to make it so that rather than popping and pushing a bunch, we kind of need to we can do this the dirty way or the good way. So the good way is to figure out how to lop off sections and then add them in, which sounds like a linked list type of operation, you know? Though I'm actually kind of, I think actually I'm fine with the stacks because it still allows us to pull off the top in the way that I want. The shoving stuff on and off the back of arrays is a little gross. So instead what we'll do is rather than, all we have to change is this for each rather than pushing and popping. What we need to do is we need to do this little iterator part twice. And we need a stack character temp stack equals new stack. Wonderful. So now I need temp stack dot push this, and then I need this to be temp stack dot pop. So now because we're moving it through a thing in the middle, it'll be fine. It basically reverses and then reverses again. So it won't be the most efficient thing in the world. Let's set this to part 2. Oh man, I don't like this one. Next one. Oh, we're a genius. Look at that. Took us forever to do part 1, and then we get to do part 2. Let's return to my advent calendar. Let's go to the leaderboard and my personal stats. 3,700 and then 3,200 because it took us 2.5 minutes to do part 2, including reading it. And let's go to our private leaderboards real quick. All right, so I don't remember the thing. You guys can look in the video, but I don't remember what we had before then. But we beat Brian on part 2 at least, which feels good. Let's refresh. Maybe he finished part 3 or part 2 right now. He did not. And if we look, no one on Ryan's. It looks like it's just me, Ryan, and Sanjguna, whoever that is. These other 2 people haven't done anything past day 1, and neither of them has even attempted this day, or at least neither of them has done day 1. So I feel pretty good about that. Okay, let's go back through and do our normal thing. First, we're going to add the stuff and clean up the code. So here's the problem statement, and let's go through our normal thing, blah, blah, blah. We copied too much. Here's this, marked crates. What's nice is that we can use the, we can use this over here to see when there are things that we're going to want to do. So this is the first part that we're going to care about. Look at that, so much better. And then we want to put a space here. There we go. Look at that. Looks so nice. Man, this one is heavy on the drawings. Okay. 2 crates. Z is the bottom, and it's on the top. Stack 2 contains 3 crates. That we goofed up the spacing there. They are M, C, and D. Man, it's nice to know that stuff like, oh, we'll just shove another stack in there and it'll solve all the problems, did solve the issue. And now we're going to go back and make this code marginally more maintainable. From stack 1 to stack 3. D, second and third crates. I just want the spacing to be like nice and spaced out here, you know? I don't really mind if the file's real long. Oh, we need to be fixing that this is off by 1, which is an easy fix. There we go, much better. Stack 2 to stack 1 again. Crates remove 1 at a time. Crate, that got way too far there. We're making some good little progress here. 1 crate is moved from stack 1 to stack 2. We want another line here. All space. And let's double check that all of them above me are good. Yes. In this example, C in stack 1, M in stack 2, Z in stack 3. Oh, this is reading so nice. CMZ. Yes, part 2. So you wonder. Crate mover 9001. Okay, so again, considering the same thing. Let's do this. Haha. Stack 2 to stack 1. Stack 1 to stack 3. Wonderful. Stack 2 to stack 1. Man, if this isn't engaging content, I don't know what is. Although, actually, I watch stuff like this, and I find it nice. Even when people aren't doing super interesting stuff, it's just nice to have something on in the background, you know? In this case, me listening to just like some light, copyright-free, attribution-free, you know, jazz-ish music from YouTube is not the worst thing in the world. Delete. There we go. Okay, cool. So this is nice. Let's go ahead and commit this. Actually, let's go back to the level real quick and add some comments. Okay, so we don't need collections, and we didn't end up using debug, though I like having that thing there. So let's see. We start by 1, Analyzing big data structures. Read in the crate stack. Reverse each stack. Align data. Parse and apply each crane move. Top boxes, wonderful. And for this one, we can copy the same, initialize big data structures, read in the crate stack. Here, initialize big data structures. Read in the crate stack, wonderful. Reverse each stack because you read them from top to bottom. Align the data. And then read and apply each move. And let's go back to the top one. Crates move one at a time. So you can just push / pop them directly. And then we can just copy this and then modify it for the same section down here. Crates move crates move all at once using an intermediary stack. Reverses them, so we can use part 1's solution with only 4 extra lines. Reverses them for insertion, so we can use part 1's solution with only 4 extra lines. Wonderful. Let's go ahead and commit this. So if we commit it, this is solution for day 5 with comments, and then we'll explain what's going on. Commit and push. There are 11 warnings. There are so many warnings. All right, everything's in there. We done did it. Fantastic. Okay, so let me explain what's going on here. So what's happening is, if we look at our problem statement here, and we just look at the nice version of the problem statement, basically there's columns or stacks of crates. And in part 1, anytime you want to move anything, for example, say we want to move one crate from here to the top of this stack, then it just moves. But anytime we move multiple crates, so say we move all of the crates in column 1 to column 3, then they move one at a time. So D is the top, but now D gets moved, and then N gets moved, and then Z gets moved. So Z was on the bottom, now Z is on the top. So as we go through, how do we solve that problem? Well, first, we'd read in the data, and then we read the data into this data structure. So this is a list of stacks. So each stack we represent with a stack where we can only grab the thing on the top. And then the list is just so we can have multiple stacks, and we can have however many there are. If we look at the actual data and we go up, we can see that there are 9 stacks. So that's fine. And there are 8 things. So we just go ahead and read that stuff hard counted. So now what we do is for each command, which is written like this, we split the string up, and then, oh, actually one thing real quick. So when we're initializing the stacks, one thing that I realized is if we look at this, and if we push this, then we push this, then we push this, and then we push this, and so on, because we're reading the file from top to bottom, our stack is actually in reverse order. This is at the top of the stack, but it's meant to be at the bottom of the stack. So what I had to do is I had to go through and reverse the stack, which I did by pulling the stack out into an array and then reading that array back in reverse into the stack. No problem. So then what I do is I do a little bit of data parsing stuff where I skip a couple of lines. And then what I do is I read the command, which is how many boxes do I move, which stack am I moving it from, and which stack am I moving it to. And I just assume the data is correct. If the data is not correct, then we can fix it later, which in these problems, the data is always correct, so you never have to worry about it. In real coding, you'd code much more defensively, and there'd be a lot more going on there. So what we do is we just push it onto the stack that we're going to, and we get it from the stack that we're going from, and we pop it, and we do that however many times it told us to do for every line. We do all of that stuff, and at the end, we just grab the top box by peeking from each of the stacks in our thing, and then we're done. So for part 2, what it tells us is, hey, so actually, like when we're moving one crate, it's the same as before. But when we move these 3 crates, like D should stay on the top actually. So it should be DNZP, not ZNDP. So basically D was on the top here. And even though we moved all 3 of the crates in column 1, D stays on the top when it goes to column 3. So that actually only requires a small modification of code. We read all the same stuff in, we reverse all the same stuff, we go through, we find how many we're moving, we go from a stack, we go to a stack, and then all we do is we push it into a temporary stack. So what happens is when you push from one stack to another stack, as you grab each item and you put it in, what was on the top now becomes on the bottom of the ones that you're moving. But that's not what we want. What we want is when you grab a chunk, the whole chunk moves. Now for stacks, there's no good way to do that. So we can either go and use a different data structure, like use a bunch of array lists and then grab the top however many elements and insert them. But that seems a little gross. The easiest thing for me to do is, well, if moving from one stack to another reverses it, I can just put another stack in the middle and it gets reversed and then re-reversed, and then it's back in the same order that it was before. And that's way easier than going back through and changing all the data structures. So I just created this new temp stack. And in fact, this can go underneath the comment now that I think about it. And then what I do is I push stuff to that temporary stack, and then I push stuff from that temporary stack onto the stack that it's going towards. So it reverses, and then it re-reverses, and then everything's in the correct order. So that's all I've got for you guys tonight. I'm going to go ahead and sign off so that I can create this video, and then I've got work in the morning. So I hope everybody has a lovely Sunday evening or Monday morning or whenever you're watching this, and I will see you guys in the next one.